learningspace.com.ng.
Today, I'm going to take you through the rudiments in answering chemistry practical questions, especially in volumetric analysis and qualitative analysis when it comes to exams like WAEC, NECO, and the likes of the O-level exams. So I will take you through revision questions, and these revision questions will enable you to be able to tackle problems when it comes to the examinations. I will start with the titration questions, like titrimetry when it comes to a real practical. Now, let's say in question 1, for majority of the exam that's at O level, is usually titrimetry, that is on titration, where you have an analyte and a titrant. Like the analyte is what you are analyzing. The titrant is the standard solution that you are trying to titrate against the analyte to get the standard concentration. Now, let's go to a specific question. Question 1. Let's say we are given an acid. A is a solution containing 9.89 gram of an acid HX per dm cube. They didn't tell us what the acid is. They just tell us the acid is HX. Then it contains 9.89 gram per dm cube. That's, in a way, they have given us the mass concentration. That's concentration in gram per dm cube. B contains 4.00 gram of sodium hydroxide per dm cube of solution. Okay, B is the base, A is the acid. Now, the procedure is this. Put A into the burette and titrate against 20 cm cube or 25 cm cube portions of B using methyl orange as indicator. Definitely you will need an indicator to determine the endpoint of titration. So repeat the titration to obtain consistent titers. Then tabulate your readings and calculate the average volume of acid used. The equation of the reaction involved in the titration is HX plus sodium hydroxide, giving you NaX plus H2O. Okay, you have been given all this. Okay, now in the titration, after the first titration is going to give you the table for your titration. This question, when you want to write question, the question number will be at the top. So this is question 1A. Then in the question 1A, you are told to what? To titrate. So you are going to prepare the table for the titration. In the table, we are going to have a final burette reading. The unit must be there in centimeter cube. At the top, then we have the initial burette reading in centimeter cube. Then titer value in centimeter cube. Okay, now at the top here, we'll divide this into 2. This section is for this vertical section. This is for the horizontal section. Here is indicating the readings. And here is for this section, which indicates the what? The trials. Okay, in the trials, the very first one is going to be the rough, which you are going to cross out in order not to confuse the examiner that it is part of your main reading. Then we have the first trial, second trial, we have the third trial. Now, in the titration experiment, when you are doing the rough, let's assume that our titer value that we will obtain after we have titrated, because this segment is just to put you through the rudiment on how to answer those calculation questions. Let's assume that the volume of base that we use from the pipette is 25 centimeter cube, and in a way, the titer value after the titration, probably it is 15.9. If our titer value is 15.9, our rough will be somewhat around 13.1, 16.1 or 16.2. So if the initial burette reading is 0.00, after the first titration, we are likely to get something within the range of 16.10 or 16.20 as the rough. So our final reading here will be 16.10. Now, if we start from here, from this 16.10 in the next one, and we have 15.8, this is going to give me 7, this is going to give me 1, 3. So my final burette reading here will be 31.7. So the difference between the final and the initial burette reading is going to give us 15.80. Okay, then we can start the burette probably from 10 again. That is when you fill the burette to something around 10. Let's assume that we are not filling it to 0. At the end of the day, we have 25.90 as the final burette reading. The difference between this and this is going to give you 15.90. Then if we continue from this 25.90, and in the 25.90, the final burette reading, we eventually have this. As we are titrating, we have a 41.90. So we have to do the difference between the final and the initial burette reading, and that gives us 16.00. Now for the rough, we have to cross the rough out so as the examiner will not confuse that for the volume of acid that is being used. Now, if you want to find the average volume of the acid used, that is average titer. Average titer is VA. It will be the first trial reading plus the second trial reading plus the third trial reading, all divided by 3. The average titer now give us 15.90 centimeter cube. So they gave us the equation, and from the equation we can get other parameters that you have been asked in the question. And what are those other parameters? If you go to question B, as indicated in the question, we have from your result and information provided, you should calculate the concentration of B in mole per dm cube. Okay, we should calculate the concentration of B in mole per dm cube. We'll go into that question. Then you should calculate for question BII. So you should calculate the concentration of A in mole per dm cube. Then question BIII says you should calculate the molar mass of HX. Then question 1C says that you should state whether the pH of the following solution is lower than 7, greater than 7, or equals to 7. That is solution A before titration, then solution B after titration. Okay, let's move to that question 1B. Having obtained the average titer from the titration experiment, we obtain the average titer to be 15.9 centimeter cube. Okay, question B states, from your result and the information provided above, calculate the concentration of B in mole per dm cube. II says that you should calculate the concentration of A in mole per dm cube. Then III says that you should calculate the molar mass of HX. Then question 1C says you should state whether the pH of each of the following solution is lower than 7, greater than 7, or equals to 7. But that is when solution A, that is the solution A before titration, you should state the pH, and solution B before titration, you should state the pH. Now, that question 1B, you have to write. Remember not to write on either margin, you will be penalized. For question 1AI. Now, in the question, they say you should calculate the concentration of B. At the beginning, you have been given that the sodium hydroxide has the mass concentration that is for B, which is our NaOH. The mass concentration, that's concentration in gram per dm cube, you have been given at the beginning of the question to be 4.00 gram per dm cube. So that is the mass concentration. Now we are told to look for molar concentration, which is concentration in mole per dm cube. Molar concentration is the same thing as mass concentration in gram per dm cube divided by molar mass in gram per mole. Mass concentration is measured in gram per dm cube. Molar mass is measured in gram per mole. Okay, now, so what is the molar concentration? That is a kind of CB. That is concentration of B in mole per dm cube. So what is the CB according to the question? Your CB is going to be mass conc. We have been given to be 4.00 gram per dm cube, all divided by, this is gram per dm cube. Then the molar mass of sodium hydroxide is 40 gram per mole. By the time you calculate sodium, you have been given to be 23, then oxygen 16, hydrogen 1. If you calculate NaOH, you will have 40 gram per mole. You will see that this mole will go up, gram will cancel each other, then the dm cube will come down. So you are going to have the molar concentration of B to be 0.100 mole per dm cube. That's concentration of what? Of B in mole per dm cube. Then the question 1BII says you should calculate the concentration of A in mole per dm cube. Remember, we are given in the equation that the acid, which is HX, aqueous, reacts with the base NaOH, aqueous, to form salt, which is NaX, aqueous, plus water, H2O, liquid. Now, here you know that the concentration of Ca is concentration of A in mole per dm cube. Then Va, that is the average volume of acid used, which is 15.9 centimeter cube. Number of mole of acid, as you can see in the equation, number of mole of acid reacting is 1. Then your Cb, which is molar concentration of base, as we have obtained from question 1AI, is 0.100 mole per dm cube. Then Vb, which is volume of base used, as we presume in this titration, we are presuming that we are using 25 cm cube of the what? Of the base. So if you are using 20 cm cube of the base, you can comment in the comment section for the likely titer value that you will obtain from this kind of titration. So I'm going to reply to your comment. So you have a 25.00 centimeter cube, and the number of mole of base, as you can see, the base in the equation, the number of mole of base is still 1. Now, using this formula, using Ca Va all over Na is equals to Cb Vb all divided by Nb. You will see that what we are looking for is actually the concentration of the acid in mole per dm cube. Then you already determine the volume of acid from titration, then the number of mole of acid from equation, the concentration of the base in mole per dm cube, we have calculated it from 1BI. The volume of base used, that's the volume that is pipetted, which is 25 cm cube. So if yours is 20 cm cube, let me know. Then number of mole of base, 1 from the equation. So we can substitute these values. Substituting the values that we obtained in our previous calculation, we have our Ca, which is what we are looking for, times 15.9, which is a titer value, all divided by number of mole of acid, which is 1, is equals to molar concentration of the base, which is 0.1, times volume of base used, which is 25, all divided by 1. So what is our Ca? That is 0.1 times 25, that is going to be 2.5, all divided by what? 15.9. Okay, so the Ca is going to give us, if you use the 2.5 to divide our 15.9, it's going to give us something approximately 0.157 in mole per dm cube. That takes here the concentration of A in mole per dm cube. Now, the third question, which is question 1BIII, states that you should look for the molar mass of the acid HS. Now, if you look at the calculate the formula for molar mass equals mass concentration in gram per dm cube, Remember, we have been given that in the question as 9.89 and divided by molar concentration, which is what we just obtained here. That's concentration in mole per dm cube. So by the time this dm cube will cancel dm cube, you are going to have gram per mole in the long run. So the molar mass of HX is now going to be the mass conc, which is 9.89 divided by molar concentration, which is 0.157. And by the time we input this in calculator, we are going to have approximately 53 gram per mole as the molar mass of HX. Now, the question C, that's question 1C, states that you should state the pH of solution A before titration. So solution A before titration has a pH, since it is an acid, has a pH that is what? Less than 7. Are we there? That is anything below 7. And solution B, since it is a base, it is not a neutral solution, before titration will have a pH that is greater than 7. When the pH is equal to 7, it means it is a neutral solution. So in these two cases, we have a pH less than 7 for solution A before titration, so pH greater than 7 for solution B before titration. So we will move to question 2, and usually our question 2 is on qualitative analysis. So let's go there. Question number 2 is usually on qualitative analysis, where you will be carrying out tests on cations and anion tests. But in this case, we are told that C is an organic compound, D is crystals of iodine. Okay, so you carry out the following exercises on C and D. Record your observations, state the conclusion you draw from the result of each test. Now, in this case, let's assume that the sample C that we are given is a kind of propan 2-ol, which is a secondary alkanol. And if you see the secondary alkanol, we'll be having this kind of formula: 1, 2, 3. The alcohol group will be on the second carbon atom, then the remaining hydrogen atom will be here. Like, let's say the organic compound you are given is propan 2-ol, and D is iodine crystal. They already mentioned it there. They now ask us to carry out the following experiment. Are we there? Now, we are to divide D into 2 separate parts, right? So about 2 cm cube of portion of C, they say you should test with litmus paper. So if C is propanol, propan 2-ol, alcohol generally, they are neutral solution. So they have this neutral effect to litmus paper. If you test it with blue litmus paper, if you test it with red litmus paper, you are not going to see any color change. So if you test it with litmus paper, in your observation, you are going to write there is no color change. I'm going to present the table to you, how you are going to present when you are presenting your answer in the exam. Like I told you, this is a revision question, and it's just to enable you to know how to answer these questions. Okay, now that is for question 1AI. The question 1AI, they said to about 20 cm cube of portion of C, which we know to be propanol. On a normal good day, you are not supposed to know if this is propanol or not. You are just supposed to be carrying out tests on a sample that you have no idea about. So you add acidified potassium heptaosodichromate 7 solution in XX. Now, when you add potassium dichromate or potassium permanganate to alkanol, alkanol will be oxidized into alkanal if it is primary alkanol. But look at this alkanol we are talking about here. This is secondary alkanol. It's going to be oxidized into alkanone. Now, if you oxidize it into alkanone, then oxidation, once it takes place, but acidified potassium dichromate is usually orange in color. If it oxidizes something else, what it will be oxidizing is a reducing agent. It's going to turn from orange to green. So if you add acidified potassium dichromate and it turns from orange to green, you will see the solution turns from orange to green. That is your observation. I'm going to give you the entire table. Then in your inference is going to be a reducing agent is present. You cannot say specifically ethanol is present, ethanol is present. You cannot state that what particular alkanol is present. You just have to state that a reducing agent is present, because it's only a reducing agent that will be what? Oxidized. But they told you that this C is an organic compound. Okay, now let's look at the next question that says that to about 2 CNK portion of C, add sodium hydroxide followed by crystals of iodine. Good. Now if you add sodium hydroxide followed by crystals of iodine, which is sample D, this test we call it Iodophone test. And in the Iodophone test, there are about 3 chemical substances that test positive, if not 4. We have acetaldehyde, and what we are talking about here is aldehyde that have the aldehyde group at the extreme of the carbon. This will test positive for iodophone test, and it's going to give you a yellow precipitate. The second thing that is going to test positive, ethanol specifically tests positive for iodophone test. Then secondary alkanol, I would say not just secondary alkanol, a secondary alkanol that is terminal secondary alkanol. That terminal secondary alkanol means that it has a methyl group at the just after the carbon atom that is bearing the hydroxyl group. Like we have the alkyl group, we don't know how many carbon is here. Then this bears this hydroxyl group, then it does have one methyl here. This is what we are referring to. This will also test positive, which means that what we are given here, it will also test positive. Then acetone, or let's say ketone. Ketone is otherwise known as what? Alkanone. So you can see that in this experiment, the inference is ambiguous. You cannot state one particular compound or one particular group that is present in that sample. If they give you this, iodophone test is made by adding sodium hydroxide and iodine crystal to a sample. And that sample, let's call it what? The sample here, we'll call it C. Okay, now you are going to observe a yellow precipitate observed. Now, your inference, the moment you just say propanol present, you will fail, because it means that you have seen the question and you know the actual chemical compound that is there. Because that yellow precipitate, we have 4. I mean, let's say the category is 3, because this is an alkanol, this is an alkanol too. We have 3 categories of organic compound that test positive with this iodophone test. So in your inference, you are going to mention that aldehyde group is present, hydroxyl group, which is in alkanol, is present. Then in ketone, carbonyl group is what is present. Okay, so we are going to say this aldehyde, hydroxyl, or carbonyl group may be present. Okay, let's now see how you are going to present the table if you are given this experiment. Okay, I've explained the rudiments of what it takes. Now, let's see how the table looks like. So let's see how we present whatever the information that we are given, and based on the experiment that we have carried out, let's see how we present this. Now, in this question 2a, if you present the table is going to be like this. We have the first one, test. Then next, observation. The last one is going to be inference. So in the question 2a, they said to the portion of C. In our mind, we know what is present in there. I'm just trying to give you a particular hint because this is aimed at real practical. If I want to give you the one of alternative to practical, there is a way that question has been set. We'll be doing that in another segment. So you add C plus litmus paper. So now in your observation, no color change observed. So in your inference, you say neutral solution is present. That means that the solution is neither acidic nor basic. Okay, in the question 2aii, they said to about 2 CNK portion of C, add acidified potassium heptaoxodichromate 7, right? So that means that C plus acidified, and if you want to acidify potassium heptaoxodichromate 7, you are going to add H2SO4 to the potassium heptaoxodichromate 7, which is K2 Cr2O7. So this is an oxidizing agent. So if it undergo oxidation, it is a reducing agent that will be oxidized. What you are going to observe if this is a reducing agent, because we know that alkanol, they are reducing agent. That is why you can oxidize them. The only alkanol that is not a reducing agent is the tertiary alkanol that cannot be oxidized. So solution, your observation, what you are going to see is solution turns from orange, which is the usual color of K2Cr2O7, to green. So your inference is not anything. Your inference should be reducing agent is present. Now in the third question, I. Now we are told that to another portion of that C, which is C, sodium hydroxide solution is being added, followed by addition of iodine crystals, which is D, right? Okay, this is what I call iodophone test. Then what you observe is a yellow precipitate was observed. Now, if you observe a yellow precipitate, knowing fully well that this is iodophone test, you cannot infer one thing. So you have to say carbonyl group, which is from alkanone, aldehyde group, which is from alkanal or aldehyde, or hydroxyl group, which is from alkanol, is suspected. This is going to be your table. So then, apart from the qualitative analysis, there is other question that they will ask you, which we have in that 2C. In 2CI, we are told that ammonium silver nitrate, they say you should state what will be observed when ammonium silver nitrate solution is reacted with propanol. Then II, they said you should state what will be observed when ethanoic acid is reacted with sodium triisocarbonate 4 salt. Now, in the first one, when ammonium silver nitrate is reacted with a propanol, you are going to see a silver mirror precipitate. So you are going to write it as silver mirror precipitate would be observed. I would have, you can see the equation as it is written on the screen. I'm just giving you the answer here. Okay, now for the ethanoic acid, this is acid. A typical acid is only that it's an organic acid. And when an acid reacts with carbonate, it forms salt, it forms water, and carbon dioxide will be evolved. And when carbon dioxide is being evolved, there will be effervescence. So they say, well, state what you would observe. So your answer will be effervescence occur with the evolution of colorless, odorless gas that turns lime water milky. That's going to be your answer for 2BII based on the question they are given here. Like I told you, these are revision questions. Okay, we will continue with the practical, probably the physics practical in our next segment. All is aimed at you excelling your exam with A's. Thank you.